we will examine different broadcast abstractions where we have a fixed set of processes. Each process may send a message to all processes in the set or the group. So what is a broadcast service? A broadcast service is a service where we have a set of processes, as I said, and processes can perform two actions or events: to broadcast a message M to all processes in the set, and we have the delivery of the message M from a specific source, as you can see here. We will often look to the external behavior of the abstraction. So the external behavior here is the events that are broadcast event, delivery events, and also you will see one more event, which is the crash of a process. This is what we call traces. Again, the trace will have three types of events: broadcast a message and deliver a message from the source, and a crash of a process. We also present a trace or an execution as a time-space diagram, where each process has its own timeline. We collapse this diagram into one linear representation, then it becomes a trace. So what is unreliable broadcast in our context? It is a broadcast where we have no delivery guarantees whether the sender fails or not. Here is an example where the sender failed. So P1 is a process that did a broadcast action, and then it crashes here. And we have two processes that delivered the message, whereas process P3 did not deliver the message. So what are the reliable broadcast abstractions? We look to reliable broadcast abstraction with increasing strength of reliability guarantees. So the weakest one is best effort broadcast, which guarantees reliability only if the sender is correct. Means that every process will deliver the message if the sender is correct. Then we have what we call reliable broadcast, which guarantees reliability independent of whether the sender is correct. Then we have uniform reliable broadcast, which also consider the behavior of failed processes. If a process delivers a message and then fails, what are the delivery guarantees of other correct processes? Next, we have FIFO, reliable broadcast. Can come in the flavors of reliable and uniform. It is a reliable broadcast with FIFO delivery order. Message broadcasted by the source will be delivered in the same order at the destination nodes. Then we have causal reliable broadcast. So it's a reliable broadcast with causal delivery order. The deliveries of messages will conform with the causality between the different broadcasts on the various processes. We will study all of these in detail and understand the different properties of the different broadcast abstractions. We have two broadcast abstractions that we will not discuss in this lecture. The first one is probabilistic reliable broadcast. This is a broadcast abstraction that guarantees reliability with high probability and scales to large number of processes. In fact, the algorithm that we present in this chapter will not scale to a large number of processes, as you will see when we study the complexity measures of the different algorithms. This reliable broadcast, the probabilistic one, will scale to a large number of processes, and it basically organizes a large set of processes into some form of network, and the nodes will gossip the values that has been delivered to the neighbors of each process. We will not discuss this because we need to study gossip algorithms to understand this well. The last broadcast abstraction is the so-called total order or atomic reliable broadcast. And this one guarantees reliability and the same order of delivery at each process. Total order broadcast requires stronger concept. So we will postpone this until we study consensus on sequences of values, and that will happen in part 2 of this course.